Sarah. And yeah, welcome everybody. Thank you all for joining me here in the open code garden today. Yeah, if you want to let me know in the chat, or there's literally only 3 of you, feel free to come off mute and say something at any time if you want to, so we have a bit more interactive thing. There's not very many of us. Yeah, and let me know where you're joining us from, and if you come to like the Code Garden streams before, yeah, I'd love to hear what you've thought about them so far, if you've come along, or yeah, why you've come along today, so I can make sure we cover the things that you might be interested in covering. So I've got a little bit of stuff prepared that we can go through today, but I'm also happy to go off the rails and talk about anything to do with Python that you might want to discuss, any questions that you have that you haven't been able to get answered elsewhere, or you want me to take a minute to explain more thoroughly for you. So yeah, today we will be going through how to practice some Python with some Caesar ciphers using a Microsoft Learn module. And yeah, any Python questions that you have that you're keen to get answered. Yeah, DN has been before. Love to hear it. Thanks for coming along today as well. Cool. Let's take a look at what we're using in the Code Garden. Our gardening tools, as I like to say. Today we'll be using Visual Studio Code. You can either use the native one downloaded to your computer, or you can use any of the versions of it in browser, whether it's github.dev or visualstudio.dev or whatever you like. One of those versions of VS Code would be great. We're going to also be using the Python extension with that because we're doing some Python, so we'll be needing that. And I'll be using a Jupyter notebook today just so I can have lots of different versions of our Python code. So you can see that, and I can easily push it up to GitHub later if you want to have a look at what we did along the way, rather than just making a singular Python file. But that's optional if you're following along. Yeah, so you can just use a regular Python file. So yeah, and that's what they'll use in this Learn module that we're going through today. Cool. Yeah, DN, the morning sessions do typically get a few more people, whether we're doing it on YouTube or on Teams apparently. Yeah, apparently lots of people on the west coast of the US want to join in, but we have our OG crew, our original crew joining us, especially from India and the APAC region. So we'd love to see you all here. So yeah, let us know where you're all joining from. So yes, what are we doing today? Today we're going to be looking at this Microsoft Learn module, which is about cracking some codes and revealing a secret with Python and Visual Studio Code, where it goes through how to decode a Caesar cipher, which is an old school, very basic cipher, but cracking it was a fundamental part of World War II and ending the war, etc. So that's an interesting piece of history about Caesar ciphers specifically. And yeah, so we're going to be doing doing some of those today with some Python because we've come a long way with computing power since back then. So you can easily make a Caesar cipher get cracked in just a couple lines of code. So it's going to be awesome. If you don't have Visual Studio Code, you can check out this training pathway. It's a Microsoft Learn pathway that will have how to install Visual Studio Code as well and install the Python extension. I think Sarah has, maybe you haven't put it in the chat yet, Sarah, the links to the modules. And Sarah's doing it now. What a champion. So yeah, today we're going to write some Python, learn some stuff about functions and Caesar ciphers. I have a fun little cipher wheel here to show you, which I like to use when I teach Caesar ciphers to kids, which makes it really easy to understand. So yeah, let's go over to the module first and get started there, because we're actually just going to get started by setting up our Python environment. Cool. So Sarah's just put these into the chat. So jump on those, where I'm looking at the first link here, which is Microsoft Training Module 2. As you can see in the chat, it will take you to crack the code and reveal a secret with Python in Visual Studio Code. So let's make that nice and big on the screen. And that's just what I had a screenshot of. It's got a few different exercises throughout it. They're just going to give us an opportunity to practice some Python. And it's going to take us right from the very start, but jump through a couple of different concepts to get us cracking some ciphers pretty fast. So let's get started with that. And it's taken to the end. Let's go back to the start. Cool. Okay, so we've seen this interesting cipher that I put in the slide. So that's come out of here. And it obviously doesn't make any sense. It's got these weird numbers in it, so we don't really know what they're about. But if you read the text, which I'm not going to make, I'm not going to read it to you here. You can read that in your own time. Or I will summarize it for you. Basically, it's about there being a treasure that is hidden in a secret location. And you need to crack the code to work out what it is, where that location is. So we look at this, and from the fact that it looks like a jumbled up mess of letters, and that these numbers here that all happen to be less than 26, we might also notice, which is not completely necessary, but is indicative. We can go, maybe it's a Caesar cipher, and that each one of these applies to one of the words. So a Caesar cipher is a rotation cipher, which I'll go into in a little bit in a minute. Actually, no, let's talk about now. While we're here on this side. So yeah, we've got these interesting codes and these interesting numbers that go with each of these words. And basically, a Caesar cipher rotates the letters in the alphabet. So let's go to my slide that I prepared earlier. So if we had a Caesar cipher that had a rotation of 2, for instance, we have to kind of decide which direction the rotation is going to happen. When we go encoding, it needs to go one direction. When you go decoding, it needs to go back the other direction. But let's say we had the letter D and we wanted it to have a rotation of 3. It would then get encoded to A, or vice versa, depending on the direction you've chosen. So that is a rotation of 3. Imagine if we just had a rotation of 1. All A's would become B's, all B's would become C's, C's would become D's, H's would become I's, Y's would become Z's, and Z's would become A's, most importantly. So it does loop back around. And that's when we can look at this fun wheel that I have here, which has the alphabet on it, and we can rotate the inner wheel to change what letter we're currently showing. So I use these with kids when I do it with them, because I do like to work with kids a lot. So let's just say that exact demo that I just said. We might have A becoming B, B becoming C, C becoming D, and D becoming E. Or we could make it a little bit more encoded and just spin the inner wheel to change how much of a jump we have there. So maybe we have, where'd A go? A becoming E and B becoming F, etc. So we can do that, but we don't do it with coding, because having watched the children do this, when I make them do it, it takes a very long time to do anything meaningful, any sort of long pieces of text. So we're going to make some computer to do it for us today, which is nice and easy. Cool. So let us jump forward and do some getting set up before we get to our cipher. So do put in the chat if you've done any Python before, or what kind of stuff what have you done before? What are you looking to learn? Yeah, and I'll make sure to go into detail on any stuff that might be of particular interest to you. Okay, cool. So we've got our Caesar cipher. And first up, we are going to go to the next one where we actually get started with the code, with writing some code. So I'm using Visual Studio Code today, as I said. I've already made a project. I'm actually putting this in the existing Code Garden Python repository. So that's going to be in when I upload it online to GitHub. It's going to be in the Open Code Garden November folder inside the Python, inside Code Garden, in my under my name. So that's where it's going to be. But if you are using Visual Studio for the first time to make a new project, super easy. You can make a new file, and then you can just type in the name here, and then so you either want to be ending with, you could do it as I'm doing. I'm using IPython notebooks, Jupyter notebooks. It used to be called IPython notebooks, and every time I read the extension, I go back 8 years to when it was called that. But it's called Jupyter notebooks, but it does need the .ipynb extension to make that happen. If you do want to use a Jupyter notebook, or you can use a .py file to just make a regular Python file. I'm just doing this because it will be easy for me to demonstrate what we're doing today, and I can show you what I mean. We might have A equals 10, and then I could store that for later in this box here. And then maybe I have a second box down here. I could print out A, and I've already stored it above. So I can have all these different boxes, and I might have different versions of the code as we go through the activity, so you can see how it all comes together. But you can just essentially, each one of these is a little Python file in itself. And if I run them in order, it runs from top to bottom. So that's super handy. And I can also, put a comment at the top. So this is my decoder. Cool. So I could do that. And then it's got markdown. So I can give it a nice big heading. So that's one of the benefits of using a Jupyter notebook. But it's kind of great for demonstration purposes, but you don't need one if you're doing this for yourself. Okay, so let's keep on going. We don't need this one anymore. Okay, so you hopefully have made a file now, and you probably want to call it decrypt.py. That's a great name. And then, yeah, we're going to get straight into writing some basic code to get us started, basically. Okay, cool. So I'm going to get rid of these bits that I put in here, and I'm going to, it just wants us to print something out firstly to see that we've got Python working, etc. Instead of using the example exactly as it's come out of here, I'm going to say hello code gardeners, and then I'm going to hit run. For me, it's going to print incorrectly spelt, but whatever. Gardeners, there we go. There we go. It prints just here because I'm using a Jupyter notebook. If you're using the Python file with Python extension, it's going to print at the bottom in a terminal. If you don't know if you've got the Python extension installed yet, you can go to the 3 blocks with the 1 block next to it, and you can write in Python there and make sure that you have the extension that looks like this, Python IntelliSense PyLance by Microsoft, already installed. So I could click here. I already have it installed, but you could hit install if you don't have it installed yet. So we've got that. You'll need that. Cool. And let's get rid of that. Cool. So printing, super easy, as we've just seen. Now we can, make it parrot back whatever we want it to say. But that's not always the most useful thing. That's just doing one thing. So let's get on to what we're going to do next. It does want us to add a comment. So here we go. I'm going to show you how to add a comment. A comment is just code that the computer doesn't read. It's for human eyes to read and understand what's going on. So I'll write this message, and the computer will ignore it. So you can press this, and it's just the same as it already was. So we've got that. Great. Okay, well, what if we want to, we're going to learn a little bit about variables. Variables are a way of storing information so you can use it later. It goes into an interesting analogy when you're using a calculator and you can use the last thing you calculated in your next calculation. So imagine variables are like that, but you can use them anytime later in your program because you've given them a name and you can just recall back to them. So instead of saying that all in one line, I'm going to say, let's put that in quotes, and I'm going to say that's the name, and I'm going to say hello plus name. So now I can run it, and once again, it looks exactly the same. But we could also put in here a different name, and we could make it say hello Sarah or hello Sanju. Reading your names out of the chat, so you can all be part of my code. So that's what we can do just by changing up our variable, and that would be useful if we wanted to do it multiple times and we didn't want to have to change the name every time. We could just change it the one time at the top. We could have it happen multiple times. So that'd be super useful when we're doing our cipher cracking. Okay, cool. So we've got our variable. We've printed it out. So now we need one more concept. to get started before we go into our cipher cracking. So I'm going to talk a little bit about functions. So functions, I like to think of like, it's basically a way to write the instructions to do something once and then be able to refer back to them whenever you need to use that again. So we've got a little one here, which is not a particularly useful function, but it will get the point across a bit. So this is called def chant. So we've defined a function called chant. To call the function, we need to give it a phrase, and then all the function does is print that phrase 3 times. So I can say chant. I could say hello, and then it's going to do that 3 times. I could say a different word, say yay. It's going to do that 3 times. So super easy to get that happening. So let's talk about a more interesting one. Okay, let's make a function I'm going to call deval. So we want to make it so that we're going to give it a name or a word or a phrase, and then it's just going to return the same thing. Let's start by making it print the same thing, but with all the vowels removed. So we're going to say deval. Need to define this at the start. And then we put in here what we need to give it to call this little function. I think of it like a little factory. It's a factory that does one thing, and then it's just kind of off to the side. And when you're like, I want that thing to happen, you just kind of call out to the factory with the things it needs to get the job done, and it'll give you back the result you want without you having to think about it anymore. So let's say deval, and we're going to have word, and it will give us something back at the end. But how we're going to do that? Well, I'm going to start by saying we're going to have a devowed word, and it's just going to be empty. Oop, that's not empty. Okay. Yeah, it's just empty, and we're going to build this up as we go along. So we're going to look at the word and see if something's a vowel, and then if it is not a vowel, we're going to add it to our devowed word. If it is a vowel, we're just going to ignore it and leave it out. So we're going to say 4-letter in word. Then we're going to say if letter in, and we can say all the vowels in uppercase and lowercase. If the letter is in those, let's say if the letter is not in, so if it's not a vowel, then we're going to say devowed word, and we're going to say equals devowed word. So we're taking that word plus the letter, putting it on the end. So just to extend it. And at the end of our loop, not before the end of the loop, because it would just, happen every time. Once we have done all the letters and seen if they're a vowel, and if they're not, we're going to add them to the thing. We're going to print it out. Okay, cool. So we've written our little function. We've made a factory thing, and now we just need to call it. So we can say deval, and then I'm going to say, let's start with my name. And then we're going to run that. That's RN. Cool. We can put another name in there. Put Jack in there. Cool. That's working. We can see down here that is in fact Jack with no letters in there. And we can say Sarah. That's all working there. Awesome. Cool. One thing we might want to do, because we can't actually use this thing that we've got back. We've got it, but all that happens is it happens in the function, and then it prints something out. And then we can't actually get this devowed word back in this case. So we need to actually return it, which says, instead of printing it there, we're going to say, I'm going to do the work, I'm going to get the answer, and I'm going to give the answer to you so you can use it for whatever you want. So you can say, okay, well, now we've got our, let's say our devowed, let's call it no V for no vowels. You can call it whatever we want, getting it back from our function. And I'm going to print out hello. And then we're going to do comma, another way to print things, separating them with spaces, put commas in between them. And I'm going to say no V. And then I'm going to run that. And now we have just got back our answer, stored it in no V, and then we've printed it out as well as something else. So we can do, multiple things we could even, take the length of no v. We can do all kinds of things because we have the data that we've got back from the function that we made. So that's what happens when you do the return. So we can see that Sarah with no vowels is 3 letters long. So we've got it back, and yeah, we can do whatever we want with it now. So that's all about returning. Super useful. Cool. Okay, so now we know about functions. That's great. We can go forth and use one to start our Caesar cipher. So here we go. We're back to our cipher. We're not going to do the whole 4 things at the same time. In fact, we're not going to do a whole word at the same time to start off with. We're going to just do 1 letter at a time because we can really break this down into a really modularized thing, which is to solve this cipher, we need to unrotate each letter in this word by 13 and unrotate each letter in this word by 25 and etc. So we just need to start by unrotating 1 letter of each word, or of any, in the general sense. We need to make a function that can unrotate a letter given the rotation that we know it is. So let us start another file, another little text box down here where I'm going to start writing our code. Please feel free to shout out and let me know if you have any questions along the way. Otherwise, I'm just going to keep on going and coding through this exercise. So, I'm going to start with 1 letter. And the module has said that the thing we're going to call our function that unrotates 1 letter is going to be called lasso letter. Scroll up a bit. Yes, we can. Okay. No worries. Cool. Okay, so we're lassoing a letter, and I don't know why we're lassoing it. I guess lasso is around. We're going around the alphabet. Maybe that's why they've called it this. I'm not entirely sure. It might make more sense to an American audience. I'm not entirely sure, but that's okay. We are unrotating a letter. So the things we need to do that computation is the letter we want to unrotate, for example, N, and the shift amount, which in this case is 13 shifts through the alphabet. So we're defining our function lasso letter that takes in these 2 parameters. Okay. So let us. So later on, we're going to need to call it. So I'm going to pop this down the bottom here. So I'm going to just write pass in here for a moment. That's where we're going to put the function. And when we call it, we want it to be able to take something that's the form of this, like A, and then 2, which is the jump. Cool. Okay, so let's talk about how we're going to do the Caesar cipher, because there's a number of ways we could do that. And the way we're going to do it is we're going to talk about the ordinate, or the ASCII number that goes with each letter, because every letter, every number, and every punctuation symbol, everything you use is characterized by an ASCII number. So capital letter A, that's 65, capital letter B, that's 66, etc. Get into the lowercase letters, they have their own numbers, 97 for A, 98 for B, etc. So we're going to use that to do some maths to calculate what we are rotating to and from, basically, because we actually have Python functions, inbuilt functions that will give us the number. And it's much easier to add, a rotation of 13 to a number like 97 than it is to add it to a letter like A, which doesn't really make any sense. So it makes the maths nice and easy. We have to be able to characterize the letter as a number, so we're going to use the ones that are already built into the computer and into the entire construct of computing systems, because we need to represent A as a number like 65, which we can then turn into binary, which we can then store in a computer hard drive. Okay, cool. So how do we do that? Well, to get a number, or the number version, or the ordinate of a letter, we just write ord. So I can write ord A. I do that. we will get 97, as we saw on the table. I could do it for any other letter or number. I've written 7, which is not the Y that I thought I was going to do, but you get 55. Or you can do, Z, get you 122. So we can use this code, really easy, to get that number, which we can then add onto to find the encoded number. So let's get on with that. So inside of our function, where I've written pass, we'll get rid of that because we have some code to put in there now. Pass is just what you write to make it not get angry that you have a block that needs indented things inside it, but it's empty currently. And we'll just skip over the contents. So let's crack on with the ordinate. So in here, we've got the letter. We need to turn that into a number before we can do our decoding. So in the instructions here, it says we can turn the letter, get the letter code, that ordinate, using this line of code here. I'm going to copy that in, and then I'm just going to speak briefly about why we're using this letter. So got this here, and which is dot lower. Basically, we're just making this as easy as possible for ourselves, even though we have some like capital letters in here. We're just assuming that that capitalization isn't important, and we're using dot lower. That's just going to take every letter, turn it into its lowercase, and then we're going to get a number for it using ordinate. That's going to be between 97 and 122, rather than dealing with the different numbers, because that'll just be a bit more logic that we don't really need to deal with. So here we go. We've got to the letter. We've turned it into an ordinate. Great. Let's just print out that ordinate. Print out letter code. Cool. Cool. So that's our encoded letter code, and we get when we call it lastly letter with the letter A, we get 97. If we put in another letter, we get a new one, 115. Cool. Too easy. So now we have that, we can use the shift amount to add on to it to work out what the decoded value is. So let's say that the decoded letter code is equal to the letter code plus the shift amount. So that's going to shift it forward in the alphabet by that many letters. So let's print out the decoded letter now. We had 115, we saw. Now we're going to run it again, and it should have 117. Cool. So we had 115, S, now it's 117. We just have to get back we went from S to 115 to 117, back to U. And the way we do that is using the opposite of odd or ordinate, which is ch or character. So we can do, so we say decoded letter, not letter code, because we're now transforming from that. So we're going to go ch, and we're going to say decoded letter code. So please give us back the character version of that, and I'm going to print that out for you. So we get U, which is exactly what we said we want. Let's say we're going to do this for the letter A, and then we should hopefully get, that's a 1. That's not an A. That's why it didn't work. You can see it still works for 1 to 3. So we get A turned into C. We could have T turn into V. We could do a bigger jump because we have the ability to do whatever jump we want now. This should get us, yep, to G, etc. So super easy to get that working so far. So great. Does anyone have any questions about that before I move on to how I'm going to break it in just a second? Cool. So now I'm going to see maybe a letter like, could we have a stream on generators sometime? Yes, we could definitely have a stream on generators. They are a bit tricky, and yeah, I have to kind of remember back to how to use yield and all those things. So yeah, I'll brush up on that, and I will do a stream on generators. Thank you, Jack. Okay, and question, another one. Could you please talk about the indentation a bit? Sure thing. So yeah, in Python, we do have indentation is important. So if you've coded something else like JavaScript or something, the indentation isn't as important because you have curly brackets and things like that that tell you when something else is inside of something, so you know where they sit relative to the other code. But here, this indentation is important because basically it tells you that this is part of this function. If I dedent this, then we don't have anything to tell you when the function starts and when the function ends, because they could have stuff here and it could just be like, oh, well, this is an empty function, or it could look like that this is part of the function. So we need to indent it, which tells it it's called a block that is inside of a function. It also applies to things like for loops and if statements. So I did this devoweling thing here. So I made a function, and inside the function, I used a for loop, which needs its own indentation because it needs to know what we are looping over. And then inside of that, I did some more indentation, which had us inside the if statement. So I'm going to make a little another one here. So if I do if, let's say name equals Renee. Okay, and then I might say if in name print that's a great name else print okay, something like that, whatever we want to do. So here's an example that we need to know that this part belongs to this if statement. So if it satisfies this condition, we do this. If it doesn't, we're going to move on to this part here. And why this is important is because you might be looking at this and be like, well, obviously the part that is in between the if and the else belongs to the first one. But if we go and look at the last part, which might be, you could have just the if statement that's just like this. You could have if, elif, and else, but let's leave it for this as this one for now. We could say something like maybe next name or something. And then we need to know if that is inside of this else statement or if it is hanging out by itself. So if we did it in here, it's just going to print great name. If there's a name, an R in my name, if I did another name like Jack, then it's going to print both of those. But we want this next name to print every single time. So we will need that, outside of the else statement. And because we don't have any brackets like this or anything to say where the else statement finishes, we need the indentation to do that for us. So that's an example for you. Okay, another question. Please decline if too advanced. What if we don't know the char or offset? Yep. E.g., are trying to decode an enemy message, Enigma code ambitions. Yeah, okay, that's a fantastic question. And yeah, it's not too advanced, I think. Yeah, and that's kind of how, this whole code breaker thing started, is because you don't always know the key and you need to be able to break someone else's cipher. So there are a few things that you can do to work out what that is. For instance, if you had an entire piece of text that was encoded with a Caesar cipher, maybe something like this. This does have, programming in it, so it's a bit trickier, but maybe it's, like something like here. It's just something that's in English. You might have things like the word A or the word I, which are like the only two single letter words in the English alphabet. And you might be like, oh, well, this Z is hanging out by itself over here, but Z is not an English word. So maybe it's the word I, or maybe it's the word A. And if you just try those two different rotations to see how far to get, Z to become A, or see how far to get Z to become I, then you know the key. So if you can find something like that in the text to give you a hint, then you can figure out the key. And once you have the key, you can decode the rest of the cipher. Maybe there aren't any single letter words, and then you don't, know what you can't have something simple like that. And you might look to something like two-letter words. There's not that many two-letter words, and if you had a computer, you could easily try all the different combinations for those. And finally, also, like, you, with the power of a computer, you could just try 26 different kinds of rotations to see like what one starts to look like English, and then you'd be like, oh, okay, this one doesn't look like gibberish anymore, that's the one, and you just read the message. So just with computers, it's very easy to do that. And yeah, in the Enigma code, I believe, like in the breaking of that, it was some parts of the messages were always repeated, like salutes to the army, basically, and finding those messages, those like parts that, you know, like said, you know, hello authority, etc. They could then work out every single day, because they had a new different code every day, but because they could always find that part in it, then they could just get a piece of communication for the new day and then find something that looked like that once they kind of had worked it out. They didn't use strictly like Caesar ciphers. They had, you know, a slightly trickier cipher, I believe, but to try and make it a little bit trickier than this, which we can do easily and not that many lines of code. But yeah, once you could find out where one of those salutes basically was in it, then you could just break the code for the day, and then their code was yours for the day until the next day. So you could easily find out where they were going to attack and understand all the communications. So yeah, I hope that was enlightening, DN. Thanks for the question. It was really good. Okay, cool. Let's continue on with our decoding then. So at the moment, it seems like it's all working, but I'm going to try it with one more example for your benefits. And I'm going to say we have the letter Z with a rotation of 6, and we can get this euro symbol, which is obviously not going to be helpful in understanding our language. So let's talk about, let's say, you know, Z with a rotation of 1, we'll get us a parentheses. So we can see, as we saw here, we get to the end and we get to character. So we've said, okay, well, it's a Z and we need to add 1 to it to decode it. And it's got us to 123, which isn't in this list, because what we actually need to do is loop back around to 97. But that's a little bit of a problem, because we've just gone off the end of this, and obviously we can see that 123 is not a letter at all. It is a squiggly bracket. So we need to make it loop back around, and that's what we're going to add to our program next to get it working properly. Okay, cool. So we are going to do this with the modulo, or mod for short, operator, which is this percentage sign that you may have seen before. So let's take a look at how we can use that and what that basically means. So yeah, modulo is essentially a way of finding the remainder when dividing by something else. So let's try dividing, let's try getting the modulo of 21 and the number 10. We can see that it's 1 because we can see that 10 goes into 21 twice and it has 1 left over. If we did instead 31, we get 1 again, etc. We did 101, we still get 1 left over. Maybe if we had 104, we get 4 left over. And we can do this for any combination of things. So we might have 21 modulo 2, and we get 1 there, or maybe we want 21 modulo 6, and we get 6 times 3 is 18, so we have 3 left over from 21. So that's what this does. So the question is, how is this useful in wrapping around the alphabet? Well, we know that if we get to the number, if we get to 122, that's the last number we can use before we need to wrap around. So we basically, if we think about the alphabet as 26 numbers, and we'll say, we'll forget about the ASCII for the moment because it doesn't start at 0 for us. So we do need to get it back down to starting at 0 before we can do this modulo. But we get our 26 numbers, and if something was then supposed to be number 27, and we then took the modulo of it, so of 26 numbers, the number of letters in the alphabet, then we'd get that it's number 1. So that's what we're going to do now, because if we had 27 number, 20, let's say A is the 0th number and B is the 1th number after that. So we're going to start at 0. If we had 25 would be Z, and then we have Z plus 1, Z plus 2 should get us to B. We have 27 modulo how many letters there are in the alphabet. Then we get the number 1, the 1th, as I'm calling it, letter of the alphabet, which is B. And that's exactly what we want. So that's what we're going to do now to add to our code to get that to happen. So, okay, let us go back up to here. And we've got our decoded letter. Okay, so now let's actually do it in a separate spot. We'll do it here, and then we'll bring it on in there because we have our decoded letter, which is not quite what we want yet. We want to go back to having the number. So we have the letter code. So let's just do an example by hand. So let's say we had a Z, and that took us to the letter code of 122. Let's say we need to rotate that forward by 2. So we're going to rotate it by 2, and then that's going to get us to 124, which is not in our letter range. We want it to actually be number 97, 98 is what letter B would be. So how do we get it to 98? So what we need to do is we're going to say, okay, well, we're going to take whatever this letter code is. So letter code, in this case, 122. And we need to, let's get it back to being based from 0 to 26, or 0 to 25, rather than between between 97 and 122, because it makes our maths difficult. So we're going to get the letter code, and then we're going to minus what the letter code for A is, which was 97. So minusing 97, so it starts at 0 for the letter A. We get that letter code, and that's going to be our kind of based letter code, and then we can add the number to it. So we can add the what have we called it? Shift amount. So now we can add the shift amount, I guess. Either way, we can put it here. Let's put it before. So we're adding the shift amount. What's the shift? Then minus 97, so we can get it between 0 and something before we take the modulo. So starting at 0. So now we have this. We can take the modulo of that, being at 26. And that will get us how many letters into the alphabet that is. So we would have had 122 became 124 minus 97, which is 27. So that would be 27 modulo 26. We would get 1, and then we would have, so number would equal to 1, and then all we need to do is add that 97 that we minused back on to get it back from being between 0 and 25 to being back between 97 and 122. So we're just going to shift it back into the actual ASCII range. So we're going to add plus 97, and then we can finally do the ordinate, get the character for that. I hope that makes sense. So that is the plan. So let's add that to this code here. So we've got the decoded letter. We've already done that. So that's this part here. So let's now get the decoded letter. Then we're going to minus, actually above here, I'm going to make the instead of just a constant value for the ordinate of A. This is all in here as well, if you want to have it written out. I'm just going to do it slightly differently from here, from what they've done, just to put the constants at the top, because we don't need to calculate what A's number is every time. We just can do that once at the start, and we also don't need to set how many letters are in the alphabet every time. So yes, they've put this in the function, but I'm going to put this up the top. Yeah, I'm going to dedent that. Okay, so I'm going to set this to be just a Python convention is to do this in capitals if it's a constant, because we don't actually have a constant data type. We only have variables. So if we're like signifying that something's not going to change, then we'll just write it in capitals and put it at the top of our file. So here we go. I'm going to subtract the A ASCII. I've left the first A as lowercase so we can actually tell that it's a lowercase a. So we're going to subtract that from our letter code, as we said earlier, is here. And then we're going to get the modulo of that. Modulo alphabet size. Cool. Okay, so that's our, I'm going to call it num letter there. Make it a bit bigger. Let's put this in brackets as well. So we've done minusing that 97, then getting the modulo. So that's the number of the letter in the alphabet. But let's not leave it there, actually. So we've got where that's up to, and then we're going to just add on the ASCII A again, just to get it back into that range. So that's going to be our decoded letter code. So we're going to override it with that. And then we can decode the letter using char. And previously, let's run this again before we turn it into a, oops, something's gone wrong. Something not quite right. Here we go. Add an extra word in there. So we can run that now. And we can see that Z now becomes A, which is exactly what we want. Let's try it again with a bigger number. Let's say Z becomes something else. Z becomes F. Y, what could Y become? It becomes E. So now we can see that it loops back around the alphabet. So before we finish with this function, I do want to turn this into a return rather than just printing it out inside the function. So I'm going to say decoded letter is equal to that. And then we can print the decoded letter out here. Okay, cool. So that's that function. And let's put this into a markdown file instead. That look a bit neater. Okay. Cool. Okay, so that is how we decode one letter. So let me know if you have any questions before I go on to how we can decode all of the letters, which is nice and simple, really, if you've done for loops before. Okay. Let us take a peek. Wait for any other letters to come through. Any other questions? Oh, so time to decode a full word with Caesar cipher. So we've got this thing that does a single letter at a time, and all we need to do is repeat it for every letter in a word. So we're going to start by making a new function. We've called this one lasso letter. Let's call the next one lasso word. So I'm going to copy that definition line because we don't need to type it ourselves. So this is all this is going to do is call the other function we already wrote and use it for every different letter. So we're going to be using for loops, which are really, like, you can do a lot of stuff with for loops. And one of the great things is whether you have a list or a string, you can do something for each item in that, what we call an iterable, something you can go through one at a time. So what we're going to do is we are going to say, just like I did for our example of a function above, where I did the getting rid of the vowels, I'm just going to do for letter in word again, which takes the word and it just knows for a string to break it up into characters and give us one character at a time, which it stores in the variable letter for us. So it takes turns at who's stored in the letter, and each of those is going to be a different letter in the word that we're giving it, which is this word that we're taking into our function. So let's copy that line. Okay, cool. So for each letter, all we want to do is decode the letter. So I'm going to call the function. So we've got our lasso letter function we just defined. We've got the letter that we're currently up to in the word. And then we have the shift amount, which is the same for the whole word, which we passed in here when we called the function. So yeah, let's just actually print that out as we go along. So I'm going to call our function with one of the words. So let us get one of the things from the question, NCEVY, and it's going to have a rotation of 13. NCEVY and 13. Cool. And I've printed it out inside the loop, so it's going to go one letter in the word at a time, and all it's going to do is decode that letter and then print it out straight away. So that's why they're all on a different line, because every time we print, it prints on a new line, unless we do some fun things with it. So we can see that it's working and that this decodes to April. So that's great. And now we, just kind of want to be able to build up a whole word rather than have 5 individual letters or however many letters are in the word. So to do that, I'm going to make a little, we're going to build up our word as we go along. So as it says here, we're making our decoded word. And we're setting it just like I did with the vowels. So removing the vowels from the name, I'm making an empty string that we can add on to as we go. So we've got that. Now, instead of printing it out, we're going to add on to this one. And we could do decoded word again here and add to it, just like it does in the code that you have access to here on the site. Like in this line, but that's a bit cumbersome, and you can actually do, I'm going to give you a hot tip, which is if you just want to add something onto the end of something, or say you had a number and you so wanted to add on to that number rather than replacing the whole number, you can just say, okay, I want to plus equals, which is add on to the existing thing, and I want to add on this letter in this case. So cool. So here we go. And then I'm just going to return decoded word. I'm going to return that outside of my for loop. So that's that indentation being important again. And we're just going to save it in a variable and then print out decoded. We can see now April is one word. Cool. Okay, we've got a question from Dan. Instead of all this freaky math, why not use 2 dictionaries, encode and decode? Build the dictionary, e.g. one step of the wheel, so that encode key is A and B, etc. And then, yep, so okay, now we can include digits, spaces, etc. Yeah, so this question is about why don't we just store that A should become C and then D should become F, and then also have a reverse dictionary where F becomes D, etc. So you could definitely do that. It does mean you need to build up the dictionaries, and you could do that by hand. So there's actually another kind of cipher called a substitution cipher, which you can just replace any letter with any other letter. So you maybe A becomes J, B becomes a question mark, C becomes a smiley face, whatever you want, really. You could do anything. And you could store that in a dictionary, and that's how I would do that if I was going to do that. It's, easiest way to do that. And then probably, having a reverse dictionary if you want to be able to decode quickly with not much code. But for this one, that does involve you have to store it. And this one, you can just do it on the fly. So you don't have to store it because it is just a mathematical process. So yeah, the maths in this one is a bit tricky because we are using ordinates and then the characters of those. But you could do it other ways, when I teach it to kids, I actually get a list, or you can just even go letters is, you know, let's say A, B, C, D, E, F, G, H, I, J, K, etc., and write out the whole alphabet there. And then you could just ask for, if you needed to decode the letter D, you could look up where D was in this using letters.index D, and it would tell you that it's in the third spot, counting from 0. And then you could add on your key of 2, maybe get E, F, which you get 5. So let's say let's, get, now we can do letters, and let's say 5, assuming you've added 2 onto it, and you get F. So that's a bit easier. You didn't have to do as much of that, like ordinate and char and all that kind of stuff, if you just want to have this. And you can even get this string out. If you don't want to write it out, you can use the string library to just import the alphabet. So something like that is also another way to do it, which means you don't have to think about ordinates and char and ASCII tables or anything like that. So that's another way you could do that. But yeah, we've basically done the code, and let us just finish it off. There is all this code here for you. You can just copy it all yourself to test it out. And yeah, let's just let's give it all a go to see what these things decode to. So I'm going to make a new little area where we can run all of our stuff. So here they've given us an example here that has this layout of shifting some word by some key, where we now call our function to shift the word, lasso the word, then it will print out the answer. So we can do that. Yeah, here's the entire code. It's got the comments in it, which is also really good. And yeah, let's actually find out what the answer is, because I've got all the code there, and we could format this in any way we wanted, really. But let's just go with the one that we've got here to copy in all these weird encoded words, so we don't have to write them ourselves. And then we hit go, and we get April 4th, Contosoville. And that is the answer to our secret puzzle. So of where the hidden treasure is. So yeah, that's how we do a Caesar cipher. Which is, yeah, really fun, really clever way to, get started with cryptography and thinking about how, data is just represented with numbers, and, you can manipulate it in any way that you want. So yeah, Sarah has put a little survey for us in the chat. If you could do that, we'd absolutely love it. We'd love to know what you enjoy about the Code Garden and anything we do in the reactor, so we can keep doing good stuff. So yeah, if you can do that, that would be fantastic. But yeah, does anyone else have any questions right now? Yes, the tutorials will continue to be available. These are all just on Microsoft Learn. So you can access all kinds of tutorials on Microsoft Learn, which is also super cool. You can go into training and you can look up all kinds of stuff. Maybe you want to get started on what is in here. There's all kinds of things. Let's go back to the browse. That's my favorite place to go to see the just huge amount of stuff that's on here. They're always here. And yeah, whether you're learning to deploy a website or want to learn about, I don't know, container-based coding and deployment, or using any of the Microsoft tools, there's stuff on here for everything, even some stuff like how to get a career and all kinds of really cool stuff. So Power Platform, yeah, check that out. They're always there. And this video will also be up online later, so you can reflect back on this if you want to have a look. Yeah, cool. I think, look, we're at time. Always happy to answer questions if anyone has any others. But otherwise, thanks all for coming along. And oh, I do need to show you that next fortnight we're doing another module. So you come back in 2 weeks. We'll be practicing Python with quiz games. We'll have the next module in the Microsoft Learn pathway. And yeah, so you can sign up for that one, just where you signed up for this one, and check out all the previous recordings on my site as well. So yeah, thank you all for coming along. Feel free